Hello guys, welcome to my channel. Today we are going to study 4.3 exercise. Before that, let's learn the introduction of that, the completing square method. In that, we have to make this equation in the square format, a plus b whole square or a minus b whole square format. For that, we have taken an example 5x square minus 6x minus 2 is equals to 0, and we have multiplied it by 5. And it comes out to be 25x square minus 30x minus 10 is equals to 0. And it can also be written as 5x whole square minus 3 minus 2 into 5x into 3 plus 3 square minus 3 square minus 10. For completing the square, we have used addition and subtraction of 3 square. We have written it in the format of 5x minus 3 whole square minus 19 is equals to 0. 5x minus 3 whole square is equals to 19. Removing the square, it comes out to be 5x minus 3 is equals to plus or minus under root 19. And the roots of x is 3 plus or minus under root 19 upon 5. Standard quadratic equation form is ax square plus bx plus c is equals to 0. If b square minus 4ac is greater than 0, then there are two distinct roots. If b square minus 4ac is equals to 0, there is a single root. And if b square minus 4ac is less than 0, then no root exists. If the real root exists, then it can be found by the formula minus b plus or minus b under root b square minus 4ac upon 2a. In that, b square minus 4ac is known as discriminant. Now we are starting exercise 4.3, question number 1 and then number 1. We have to find the roots of the x of given equation by the completing square method. The equation is 2x square minus 7x plus 3 is equals to 0. And for that we have to take it in the form of square. So that we will divide the equation by 2. So x square minus 7 by 2x plus 3 by 2 is equals to 0. Taking 3 by 2 on the other side, it becomes negative. And we get this third term by b upon 2a whole square. By doing this, we get 7 upon 4 whole square as a third term. And adding them both the sides, it gives us perfect square equation. X minus 7 by 4 whole square is equals to 49 upon 16 minus 3 by 2. And by solving this and removing square from both the sides, we get x is equals to plus or minus 5 by 4 plus 7 by 4. So x is equals to 7 by 4 minus 5 by 4, or x is equals to 7 by 4 plus 5 by 4. And the two roots of x come out that they are 1 upon 2 and 3. Moving to number 2, 2x square plus x minus 4 is equals to 0. Same as question number 1, we have to divide this equation by 2. X square plus x by 2 minus 2 is equals to 0. By taking minus 2 on the another side, it becomes positive. X square plus x by 2 is equals to 2. And for third term, we have used the formula b upon 2a square. From that formula, we have find 1 upon 4 whole square to make it a perfect square. So it is x square plus x by 2 plus 1 by 4 whole square is equals to 1 by 4 whole square plus 2. The perfect square is x plus 1 by 4 whole square is equals to 1 upon 16 plus 2. X plus 1 by 4 whole square is equals to 33 by 16, and removing the square from both the sides, we get x is equals to minus 1 upon 4 plus or minus root 33 by 4, and the roots of x we get here is minus 1 minus root 33 by 4 or minus 1 plus root 33 by 4. In number 3, 4x square plus 4 root 3x plus 3 is equals to 0. On comparing this equation with ax square plus bx plus c is equals to 0, we get a is equals to 4, b is equals to 4 root 3 and c is equals to 3. And the discriminant is equals to b square minus 4ac, which is equals to 4 root 3 whole square minus 4 into 4 into 3, which is equals to 48 minus 48 equals to 0, which means that real roots exist, means both the roots are same here. So x is equals to minus b plus or minus under root d, discriminant b square minus 4ac upon 2a is equals to minus 4 root 3 plus or minus under root 0 upon 2 into 4, which is equals to minus 4 root 3 upon 8 is equals to minus root 3 by 2. Question number 1, number 4. 2x square plus x plus 4 is equals to 0. We divide this equation by 2. So we get x square plus x by 2 plus 2 is equals to 0. Taking the 2 on another side, it becomes negative. X square plus x by 2 is equals to minus 2. X square plus x by 2 plus 1 upon 4 whole square is equals to 1 upon 4 whole square minus 2. We have taken 1 upon 4 square to make it a perfect square term. And this third term came from the b upon 2a square formula. We have added this both the side of equation. We get the perfect square x plus 1 upon 4 whole square is equals to 1 upon 16 minus 2. X plus 1 upon 4 whole square is equals to minus 31 upon 16. The square of any number can never be negative. So the roots of this equation doesn't exist. Moving to question number 2, number 1. 2x square minus 7x plus 3 is equals to 0. We have to find the roots by the quadratic equation formula. On comparing with ax square plus bx plus c is equals to 0. We get the values of abc. We have to find and we substitute the values of abc in the equation b square minus 4ac. We get the answer 13. X is equals to minus b plus or minus under root b square minus 4ac upon 2a. We get two roots of x here, 7 plus root 13 upon 4, or x is equals to 7 minus root 13 upon 4. Question number 2, number 2. 2x square plus x minus 4 is equals to 0. On comparing this equation with ax square plus bx plus c is equals to 0, we get the values of a, b and c. Putting the values of a, b and c in the equation b square minus 4ac, we get the answer 33. X is equals to minus b plus or minus under root b square minus 4ac upon 2a is the quadratic formula from which we have to find the roots of x. Substituting the values of every term, we get the answer minus 1 plus under root 33 upon 4 or minus 1 minus under root 33 upon 4. Moving to number 3, 4x square plus 4 root 3x plus 3 is equals to 0. On comparing this equation with ax square plus bx plus c is equals to 0, we get the values of a, b and c. Substituting this value of a, b and c in the equation b square minus 4ac, we get the answer 0. So two equal real roots exist here. Putting the value, so to find the roots, we use the quadratic formula. X is equals to minus b plus or minus under root b square minus 4ac upon 2a. And substituting the values of each of them, we get the answer minus root 3 upon 8. In number 4, 2x square plus x plus 4 is equals to 0. And comparing this equation with ax square plus bx plus c is equals to 0, we get the values of a, b and c. Substituting these values in equation b square minus 4ac, we get the answer minus 31, which is less than 0. So no real roots exist here. Moving to question number 3, in that number 1. X minus 1 upon x is equals to 3. Multiplying the above equation by x, we get x square minus 1 is equals to 3x equation. Arranging them in the format of quadratic equation x square minus 3x minus 1 is equals to 0. On comparing this equation with ax square plus bx plus c is equals to 0, we get the values of a, b and c. Substituting the values of a, b and c in the equation b square minus 4ac, we get the answer 13. And for the roots, we will use the quadratic formula minus b plus or minus under root b square minus 4ac upon 2a. Substituting the values in this quadratic equation, we get the roots of x as 3 plus under root 13 by 2 or 3 minus under root 13 by 2. Moving to number 2 in question 3, 1 upon x plus 4 minus 1 upon x minus 7 is equals to 11 upon 30. Taking LCM, we will multiply 1 with x minus 7 minus 1 into x plus 4 upon x plus 4 into x minus 7 is equals to 11 upon 30. X minus 7 minus x minus 4 upon x square minus 7x plus 4x minus 28 is equals to 11 upon 30. Now cross multiplication minus 11 into 30 is equals to 11 into x square minus 3x minus 28. Minus 330 is equals to 11x square minus 33x minus 308. Arrange in this equation in a quadratic form will come out 11x square minus 33x plus 22 is equals to 0. By using the factorization method, we will find the roots of this. X square, here we have first taken out 11 is common, so the equation will be x square minus 3x plus 2 is equals to 0. Splitting out the minus 3x term by minus 2x and minus x, our 4-term quadratic equation is formed. Now by pairing it and taking common out from it, we get the roots of x as 2 or 1. In question number 4, it is given that the sum of reciprocals of Riemann's age 3 years ago and 5 years from now is 1 upon 3. Find his present age. First, we suppose the present age of Riemann's age is equals to x years. The Riemann's age 3 years ago was x minus 3 and 5 years from now is x plus 5. The sum of these two reciprocals is equals to 1 upon 3. By bringing it in the form of an equation, we get 1 upon x minus 3 plus 1 upon x plus 5 is equals to 1 upon 3. By taking LCM and cross multiplication, we form the quadratic equation x square minus 4x minus 21 is equals to 0. By factorization method, we will find the roots of x. For that, we will split the middle term minus 4x in the form of minus 7x plus 3x. By pairing it and taking out common from that, we get x is equals to 7 and x is equals to minus 3. The age of any person cannot be negative. So the age of Riemann is equals to 7 years. In question number 5, it is given that in a class test, the sum of Shefali's marks in mathematics and English is 30. Had she got 2 marks more in mathematics and 3 marks less in English, the product of their marks would have been 210. Find her marks in the two subjects. So we suppose that Shefali got x marks in maths and 30 minus x in English. It is given that she got 2 more marks in maths and 3 less in English. Then the product of it will be 210. So by bringing it in the form of an equation and solving it, we get the quadratic equation x square minus 25x plus 156 is equals to 0. By splitting the middle term minus 25x by minus 13x and minus 12x. By pairing them and taking out common, we get the answer x is equals to 13 or x is equals to 2. It means if Shefali would have got 13 marks in maths, then in English she had got 18 marks, and if 17 marks. If she had got 12 marks in maths, then 18 marks in English. In number 6, it is given that the diagonal rectangular field is 60 meters more than the shorter side. If the longer side is 30 meters more than the shorter side, find the sides of the field. Suppose the shorter side of the field is x meter. Then the diagonal of the field is equals to x plus 60 meter and the longer side will be x plus 30 meter. By Pythagoras theorem, rectangle is, when we divided it by the diagonal, it forms a right angle triangle. So we can use the Pythagoras theorem here. So by Pythagoras, x square plus x plus 30 whole square is equals to x plus 60 whole square. By equating it and bringing it into a quadratic equation form, it is x square minus 60x minus 2700 is equals to 0. By factorization method, we will find the roots of the x. For that, we will split the middle term minus 60x by minus 90x plus 30x. By taking out common, pairing them, we get x is equals to 30 or x is equals to minus 30. Any side of any shape cannot be negative. So minus 30 is not possible. So the shorter side of the field is 90 meters and longer side of the field is 120 meters. In question number 7, it is given that the difference of two squares of two numbers is 180. The square of the smaller number is 8 times the larger number. Find the two numbers. We suppose that the larger number is x. It is given that the square of smaller number is 8 times the larger number. So here we have already taken the square, so we will not square it again. But for this we will. The difference of both of them is given 180. So x square minus 8x is equals to 180. X square minus 8x minus 180 is equals to 0. This is the quadratic equation form. We will solve it by factorization method by splitting the minus 8x middle term by minus 18x plus 10x. By pairing it and taking out common, we get x is equals to minus 10 and x is equals to 18. The larger number cannot be minus 10. So it is x is equals to 18. Here we have taken the square of smaller number. Smaller number square is equals to 8x. So smaller number square is equals to 8 into 18, which is equals to 144. So smaller number is equals to under root 144. So it is equals to plus or minus 12. So here there are two possibilities. The larger number will be 80 and smaller number will be 12. Another is larger number will be 18 only, but smaller number can be minus 12. In question number 8, it is given that a train travels 360 km at a uniform speed. If the speed had been 5 km per hour more, it would have taken 1 hour less for the same journey. Find the speed of the train. We suppose that the speed of the train be x km per hour. Time to cover 360 km is equals to 360 upon x kilometers. If the speed of the train is 5 km per hour more, x plus 5, then it would have taken 1 hour less. So we bring it in the form of an equation, x plus 5 into 360 upon x minus 1 is equals to 360. By taking LCM, equating them, we get the quadratic equation x square plus 5x minus 1800 is equals to 0. By splitting the middle term 5x by 45x minus 40x and pairing them and taking out common, we get x is equals to minus 40 or x is equals to 40. But x is equals to minus 40 is not 45 is not possible because speed cannot be negative. So the speed of the train is 40 km per hour. In question number 9, it is given that two water tanks together can fill a tank in 9 integer 3 upon 8 hours. The tap of larger diameter takes 10 hours less than the smaller one to fill the tank separately. Find the time in which each tap can separately fill the tank. Both the taps together fill the tank together 9 integer 3 upon 8 hours, which is equals to 75 upon 8 hours. We suppose that time taken by a smaller tap is equals to x hours. Time taken by a larger pipe is equals to x minus 10 hours. Part of the tank filled by smaller pipe in 1 hour is equals to 1 upon x. And part of tank filled by larger pipe in 1 hour is equals to 1 upon x minus 10. So 1 upon x plus 1 upon x minus 10 is equals to 8 upon 75. By taking LCM and equating them, we get the quadratic equation 8x square minus 230x plus 750 is equals to 0. By splitting the middle term minus 230x by minus 200x and minus 30x, by pairing them and taking out common, we get x is equals to 25 and x is equals to 30 by 8. X is equals to 30 by 8 is equals to 3.75 hours. So if this time taken by smaller pipe is minus 3.75 hours, then time taken by a larger pipe will be in negative hours, and time cannot be negative, so it is logically not possible. So time taken by a smaller pipe is equals to 25 hours and time taken by a larger pipe is equals to 15 hours. In question number 10, it is given that an express train takes 1 hour less than a passenger train to travel 132 km between Mysore and Bangalore. If the average speed of the express train is 11 km per hour more than the passenger train, find the average speed of two trains. Let the average speed of passenger train be x km per hour. Then the average speed of express train will be x plus 11 km per hour. It is given that the time taken by the express train to cover 132 km is 1 less than the passenger train to cover the same distance. It means the difference of the time of both the trains is given. So 32 upon x minus 132 upon x plus 11 is equals to 1. By taking LCM and solving and equating it, we get the quadratic equation x square plus 11x minus 1452 is equals to 0. By factorizing the middle term, splitting the middle term plus x by plus 11x by 44x minus 33x, by pairing and taking out common, we get x is equals to minus 44 and 33. But the speed of any train cannot be negative. So minus 44 is not possible. So speed of passenger train is equals to 33 km and speed of express train is equals to 44 km per hour. In question number 11, it is given that sum of areas of two squares is 468 meter square. If the difference of their parameters is 24 meter, find the sides of the two squares. Let the sides of two squares be x meter and y meter. Therefore, their parameters will be 4x and 4y respectively, and their areas will be x square and y square respectively. It is given that the difference between their parameters is 24. 4x minus 4y is equals to 24. So x minus y is equals to 6. So x is equals to y plus 6. The areas of both of them is equals to 468. So x square plus y square is equals to 468. But x square is equals to y plus x. So we will substitute the value of x in the equation. So it will be x plus y whole square plus y square is equals to 468. 36x plus y square plus 12y plus y square is equals to 468. By equating it, we get the quadratic equation y square plus 6y minus 216 is equals to 0. By splitting the middle term for the factorization to find the roots of y, by splitting 6y by 18y minus 12y, by pairing and taking out common, we get x is equals to minus 18 or 12. But the side of any shape cannot be negative. So y is equals to 12. The sides of the two square will be x is equals to 12, y is equals to 12 and x is equals to 18 meter. So here we have completed our exercise 4.3.